Hey everybody, this is the Pre-Med Companion with somewhat of a difficult but very high yield topic on the physics section of the MCAT, so let's go over this question related to torque. A uniform horizontal beam is balanced on a pivot at its center as shown in the diagram. A block of mass 2 kilograms hangs from the left side of the beam at a distance L1 from the pivot. On the right side, a force F is applied at the same distance L2, so L2 equals L1, making an angle of 30 degrees with the beam. Assume the beam is massless and that the acceleration due to gravity equals 10. What magnitude of force is required to balance the beam? So here, because we're trying to balance the beam, the torques on either side should be equal. So we're first going to calculate or simplify the torques on either side and then set them equal to each other and then solve for the force, which is what they're asking us over here. The equation to calculate torque, which we'll denote as T over here, equals R, which is the distance from the fulcrum, times the force applied times sine theta, which is like the angle that the force forms with the beam over here. All right, so let's start with the left-sided torque, which we're going to denote as LT. So LT, left torque, that's going to equal, so our R over here is going to be L1. All right, so L1, which we don't know the value of, times F, which is going to be mass times gravity. But we know that the block is 2 kilograms and that gravity, or acceleration due to gravity equals 10. So we can just say 2 times 10, and that's going to equal 20. So the force on the left side is 20. And then sine theta is going to be sine 90 over here. And the way I know this is because if you look at the angle right here between the block and the beam, it's a right angle. So that's 90 degrees. And therefore you have sine 90. And sine 90, by the way, equals 1. So to simplify, LT, or left torque, is going to equal 20 times L1. Okay, we don't know L1 yet, but we don't even need to know the value of it, as we'll see shortly. Next, let's figure out the right torque. So the right torque is going to equal R, of course. In this case, R for the right torque is going to be L2. So we have L2 times the force, which is unknown. So we don't know what the force is. That's what we're trying to figure out. And then the angle is 30, so sine 30. So sine 30 equals 0.5. You should memorize this. So the right torque equals L2 times F times 0.5. All right, now we can set the two torques equal to each other and solve for F. So the left torque equals the right torque. The left torque equals 20 L1. And then the right torque equals 0.5 times L2 times F. Okay, so we can simplify here by canceling out L1 and L2 because they are equal. Remember, they said this in the question right here. All right, so we cancel those out. So we're left with 20 equals 0.5 F, and then you divide both sides by 0.5. All right, so you're left with F equals 20 over 0.5 over here. So multiply top and bottom by 2. And then what you're left with is F equals 40 over 1, and that's obviously just 40. So the answer is C. Like and follow if you found this video helpful. Let me know what questions you have in the comment section down below.